The universe is everything, from the tiniest particle to the largest galaxy to the very existence of space, time, and life. But how this all began? The origin of universe is the origin of everything. Multiple scientists' theory plus creation myths from around the world have tried to explain its mysterious genesis. However, the most widely accepted explanation is the Big Bang Theory. The Big Bang Theory states that the universe began as hot and infinite standpoint. Only a few millimeters wide, it was similar to supercharged black hole. About 13.8 billion years ago, this tiny singularity violently exploded. But how does Big Bang work? How can something come from nothing? Let's explore what we know. So right after the Second World War, observation from two scientists, Rafa Alpha and Robert Hermans, come with the interesting idea looking at the constancy of the universe and realize that the universe, by and large, if you look at the star and all the planet and everything all out there, that about 75% of the universe is made up of hydrogen, and the other 25% is made up of helium. And we could look at every star in the universe, every galaxy from the element and universe, almost 100,000 of it is either hydrogen or helium, and just a very small percentage is made up of the other element from the table. They also realized when they look at the star and study the star, they understood that the every core of the star nuclear fusion was taking place, which is about the amount of the tremendous amount of energy that star produced. So, what happened at the core of the star? Is hydrogen converted into helium, and that is done through a nuclear fission process, generating enormous quantity of energy that can only take place when the temperature is at the minimum 10 million degrees. This is hydrogen are basically proton at the temperature, and the electron are stripping away ionized, so a single proton floating around in there, and to get a two proton come too close enough to each other to fuse together to eventually make helium, because a 4 proton make one helium atom or one helium nucleus. So they need the temperature of at least 10 million degrees to make a move fast, so they can collide before the repulsive force will push them away. So we understood that this is what's happening at the center of the star. Of course, that the core star hydrogen are being converted to helium until the entire core fill up with the helium. So the beginning universe is have been extremely hot. That is the thermonuclear reaction was taking place through the universe, converting a very rapid red hydrogen into helium under probably tremendous temperature and pressure. And it is from this explosion, this bang, that all matter, energy, space and time was created. What happening next were two major stages of the universe evolution, called the radiation and matter era.
Next were two major stages of the universe evolution, called the radiation era and the matter era. They are defined by the events that helped shape our universe today. First came the radiation era, named for the dominance of radiation right after the Big Bang occurred. This era is made of smaller stages called epochs that occurred within the universe's first tens of thousands of years. The earliest is the Planck epoch. In this epoch, no theory available to describe this era. Besides, no matter existed in the universe at this time. Only energy and the ancestor to the four forces of nature, the superforce. At the end of this stage, however, a key event occurred in which gravity split away from the superforce. Next came the grand unification epoch, named for the three remaining unified forces of nature. This epoch ended when one of those forces, called strong nuclear, broke away. Then, the inflationary epoch began, during which the universe rapidly expanded. There are some physicists who found this theory, which is Alexei Starobinsky and Andrei Linde. They found that the universe expands in 10 of 26 times its initial dimension, equivalent to an object of 1 nanometer in length, expanding to approximately 100 trillion kilometers long in a tiny fraction of a second. This change is known as inflation. At the end of inflationary epoch, the universe continued to expand but at a slower rate. Then came the electroweak epoch, when the last two forces, which is electromagnetic and weak nuclear force, finally split off. The electroweak epoch is said to begin after the inflationary epoch ended. So what happened next? Let's proceed to the next epoch.
The first one is warp epoch. This stage was the beginning of the formation of the subatomic particles after 10 to the power of negative 12 seconds of the Big Bang. All particles were formed and the beginning of the formation of the first atomic started. However, it was not completed even at the end of this stage. The temperature of the universe was about 10 to the power of 16 Kelvin. Next, the hadron epoch. The universe was cooled down enough for the quarks to bind together and form the subatomic particles, which were called neutrons and protons. The temperature at this stage 10 to the power of 10 Kelvin, and this stage is placed after 10 to the power of negative 10 seconds of the Big Bang. The universe got its subatomic particles called electrons, protons, and neutrons. Last but not least, Lipton and nuclear epoch. The Lipton and nuclear epoch were not different from each other, except the temperature and time of the universe. The temperature at Lipton epoch was about 10 to the power of 12 Kelvin, and it was placed after 1 second of the Big Bang. The temperature at nuclear epoch was about 10 to the power of 9 Kelvin, and it was placed after 100 seconds of the Big Bang. During this stage, neutrons and protons combine to form the nuclei of atoms, and due their mass and energies, they attracted electrons, which started revolving around the nuclei. This gives birth of the formation of the first chemical element, which is helium. Also, this stage, the dominance of radiation over matter no more, and the radiation era ended. So, the radiation era lasted 100 seconds after the Big Bang, and the temperature dropped from 10 to the power of 40 Kelvin to 10 to the power of 9 Kelvin. The era gave the universe its first chemical element, which is helium. This is the reason why helium is known as the oldest element from the periodic table. This era is also known as the inflation period, as the universe expanded from nothing to such a huge entity. So, that's all from me. Let's move on to the matter era. Faiz, it's all yours.
After those 20 minutes, we were now into what we call matter era. The temperature dropped below 10 million Kelvin, where nucleosynthesis was no longer possible. But for the next 380,000 years, the radiation that we now see as the cosmic background radiation was locked into the matter, because the matter was so hot that it was ionized then, and the electron was separated from the proton so that radiation could not freely move around the universe. Then about 380,000 years after the beginning of the Big Bang, the universe finally cooled down to about 3000 Kelvin. At that point, matters no longer ionized and electrons began to join with the protons, and therefore now there was plenty of space for the radiation to float freely through the universe and universe from being very opaque universe became a transparent universe. And then finally, we realized that the very slight differentiation in the density at the very early part of the universe then continued to display itself in the background radiation, and therefore the radiation now was able to freely move throughout the universe. Now, what happened after that was about 150 million years. The universe was completely black, completely dark pitch black, not a single photon of light, because all we had was matter that was no longer ionized. So we have electrons zipping around the proton, making hydrogen atom, and we had electrons zipping around the alpha particle, making helium, and a small amount of lithium and other elements. And radiation at the wavelength that was no longer visible light was now infrared light, which is no longer visible. There was slight density fluctuation in the very beginning of universe, which then expanded to small variation in the density of matter that was then created from the radiation in the radiation era. Those small regions where the density was slightly higher, that was along light surface region of filament region, wherever those cross one another density was high enough for the gravity to take over and start to push things together with gravity into dense enough region where stars could begin to form and where galaxy could begin to form. So we feel that somewhere about 150 million and or maybe 3,400 million years after the Big Bang, stars began to form, galaxies began to form, globular cluster began to form, and that's where the universe began to take on the structure it has today.